All right, welcome back. I hope you're enjoying yourself so far. Our next speaker is Joey Ahnn. He is a principal AI engineer at Target. Please join me in welcoming Joey to our virtual stage.
Thanks, Patricia. Let me share my screen. Is my screen visible? Yeah, I assume it is. So again, my name is Joey Ahnn. I'm a principal AI engineer at Target. Welcome to my session. So I'll be sharing my experiences around the data-centric AI product development, especially for retail, big box retailers. So it will be an interesting session, and you'll be hearing use cases of AI for retailers and some of the enabling technologies and architecture around this data-centric AI product development. So as I said, Zenda, I will be sharing use cases for AI for retailers. I will talk about some of the motivations, why we are talking about data-centric AI instead of model-centric AI. So I'm not saying that model-centric AI is worse than data-centric, but I'm highlighting that data-centric AI has its own benefit. And also talk about some of the enabling technologies for data-centric AI. So I will talk about some of the featureization process and upcoming challenges. And I will conclude my presentation by introducing some of the reference architecture for data-centric AI. So let's talk about use cases for AI in retail businesses. So as you can imagine, inventory controlling and positioning has some its own challenges. So using AI algorithm, so how do we better maintain and manage inventory controlling and positioning? That's one of the traditional problems in retail businesses. And sales forecasting is definitely another one of the important areas for retail businesses. And during the pandemic, so we particularly have challenges to accurately forecast demand, which will happen in the future. Deals. So if you give an offer to your guest based on deals, so how do we personalize and how do we understand guests better so that we can accurately provide good deals for our guests? That's another area. So of course, you can think about some robots sitting on your floor, assisting you while you're shopping. That's another interesting area to talk about. And recommendation is typical AI problems, especially for e-commerce setting. So for a given keyword, guest is searching on e-commerce website, and you see a lot of opportunities to recommend similar items or the items guests would want to buy along with. Inventory tracking on the right-hand side is another problem you've seen from media. So in this picture, you see the array of camera that are tracking the on-shelf availability. And I put the perishables example like a banana. It's very hard problem to track down. So what is the cadence of the available bananas the stores can sell. And chatbot is another good area you can think about in how we can engage with guests better upfront so that we understand what guests want. And sometimes initial engagement is led to actual the representative conversation later. So the cart is another area where you've seen a lot of innovations and ideas coming around. So how can we make our guests frictionless in terms of checkout? So let's go back to AI. So this is 2015 Google paper they published So in the core boxes, as you see the ML code, which is very small box, you see. So which means that peripheral components around machine learning systems is around data related or feature related or some of the system or infrastructure related. So the very small part, which is ML code box, is related to actual machine learning code. In 2021, as you see, famous professor, Stanford professor Andrew Ng said 80% of time people are spending for data prep within data science life cycles, which means that only 20% of data science life cycle is around the model development. So how do we understand 80% of time, and how do we see and what area we see opportunity to improve 80% so that it can be much more effective in terms of data prep and AI model development. So let's go into details. Each boxes here in this slide represent each of the data science life cycle, from understanding business need and some of the discussions with business, how AI can help. And that is kicking off data prep session, where we go and find the right data to process and understand. And it actually goes on to the model development based on all the data prep from the previous stage. So it involves featureization, model creation, and evaluation and selection. And then model can be deployed to the production environment, and business execution is involved. In red boxes I highlighted here is basically feature manager's responsibility. So when I say feature manager, you can see this as a feature store or infrastructure side data prep. And I highlighted green boxes here, which requires features from feature manager. So the end-to-end, including red boxes and green box, can explain 80% of data prep steps in data science lifecycle. To this end, so I can say that feature manager or feature store seems to be a key player in data science lifecycle. So let's think about some of the solutions out there. So the first solution I put here in this slide is Databricks feature store solution. So where they combined some of the storage solution with API solution, which gives you an abstract layer to access to the features stores in storage. Then they provide ML flow, which gives you the ability to create a pipeline for your feature products, so that the outcome from the feature product can be an input to your AI model. So as you see Amazon has feature store, Airbnb has feature store, Pinterest has one, Apple has one. So from that lens, as you see, almost all the big companies is trying to build similar to what feature store is offering as of now. So there are many open questions I can think about. As you see, big companies are trying to solve this feature store problem or feature management problem to make AI transformation faster. And I do see some of the challenges still. So one of the challenge is that how can we better build shareable features so that you process and you create a feature once, not multiple times, if it is shareable. And then another challenge I see is how can we improve time-consuming feature discovery steps or creation and selection processes? Or how can we improve featureization process, which I will talk about in the later slide. And this also can be machine learning driven, so that the labor intensive steps can be converted into ML driven process. So lastly, as I talked about a little bit in earlier slides, if it is abstract layer feature manager can provide, and how can you provide API or SDK so that everybody can access to the API as a means to access to features or as a means to create features. So let's talk about some of the feature processes to enable data-centric AI. So I'm giving several examples of how to create features and what features means in the context of retails. So if you can see some of the sales transaction data, and let's say you have some natural disaster coming, so would you incorporate those sales under natural disaster, which is an anomaly, or probably you can remove those outliers from your training samples. Or if you have some missing values from your sales data, how would you handle it? And if you have some ordinal feature and your algorithm requires integer value rather than ordinal features, how do you transform it? So here I give a t-shirt size in string, and that can be transformed into the integer. And some of the encoding, the process can be applied in featureization process. And then one-hot encoding is a pretty good example. In the case of here, the example is a stockout flag, where you can actually see 0 as a no stockout and 1 as a yes stockout. And then, so you can also think about some of the training data set, which can be converted into several splits, where you can use one part of split as a training data set, and you can use another part of split as a test data set. So normally 80-20 rules are applied, but how do you make sure that 80-20 split is actually gives you a good result for you? How do you prevent model from bias by having 80-20 rule? That's another good question. So as you can see, some scaling is one of the good example in featureization, whether this is normalization or standardization. So you can think about this as a good example. And feature selection extraction is pretty the commonly used the method, so that based on whatever feature candidate you have, you gotta select good features as a predictor so that your model can be trained on. Or extraction is another flavor of selection, so that the extraction mechanism will let you pick or convert your candidate features into another space so that it can capture as large variance as possible from your training set. So let's talk about some of the challenges. So far, we talked about why we're talking about features, what are the 80% of, the data science life cycle steps. So, but we still see some challenges, 3 different challenges I will talk about. One is, what if we have bad features? What will be outcome for that? And then, of course, you're feeding AI models with bad features, so we'll end up with low performing AI models, which means, your prediction or, forecast will not be very good. And then another challenge I can talk about is, let's say you have a huge amount of data you're feeding to your AI model, probably you will end up with high dimensional feature problem. And the model will end up with overfitting problem, which means model is trying to fit every single training data set so that it fails to generalize enough, so that by the time when you have to forecast, you use that model, and then actual model's performance is not very good. So lastly, I will talk about some of the bias issue. Even though you don't have bad features, it seems to be good features, and features are not very high dimensional, and then model is not overfitting at all. even though both cases are not set are pretty well set, then you still have a chance to think about biased features. So I will go through some of the examples in a later slide. So for the bad features, in the context of retail, you can think about data sparsity and data may be corrupted and irrelevant data as a features you can have for model training. And then labeling may be wrong. Some of the unexpected pattern may come at, for example, seasonality patterns and things like that. That will cause some of the underperforming AI model problem. And then secondly, the high dimensionality problem is that's, as I said, it may impact the model to be overfitting, which means the model is model's parameters becomes too complicated to fit every single training data you have, so that when by the time when you actually have to forecast, the model is not very well performing. Solution for that is, of course, you can think about model-centric approach where you apply regularization method so that it filters out some of the noise from training data, which is good. But what is alternative solution? Here, I'm highlighting some of the data-centric approach where you can use better feature selection method, or you can use feature extraction method so that you can expect the lower dimensionality reduction. So the lastly, bias features. How do we handle bias features? So Amazon and MIT researchers revealed that there are bias features problem on their system they built. In coming to retail setting, how do we understand this problem? So some of the potential bias I can think about is that, so let's say you have some guest level offer algorithm that provides some of the offers to your guests. And how do we make sure that, so your offers has no bias across different guests, where you see different income, race, and some of the demographic information like that. And same with recommendation. So when you do product recommendation, so how do you make sure that your model recommends the fair recommendations to your guests based on different demographic profiles? Yes, this is hard problem. So to solve this problem systematically, so we are thinking about having good systems where you can provide good infrastructure so that you can put some of the guardrails and some of the common tools and system softwares like this. So here I'm introducing feature store architecture, which is commonly referred architecture out there. So this is not specific to Target or specific to retail companies, but this is more general enough so that people can understand what should be the systems as our infrastructure to enable AI-driven, data-driven AI model development. So on the left-hand side, you see data ingestion from streaming data. Either this can be click streams or other type of streaming data you can grab. And of course, there are some batch data you can grab from some storage you have, whatever storage you have. Then those are coming into feature store, red boxes. Then, so inside the box, you see transformation, storage and serving layer and registry layer as well. So on the bottom, you see data scientists who are playing with this system. And what this guy can do is, he can define feature and he can discover features if it is pre-calculated and created. And it definitely has a transformation layer where data scientists can define pipelines to grab streaming data and batch data all together to create features based on the definition he is giving. Once features are defined and he can register features so that he can access to the features later, or somebody else can actually use the data if it is already created. So the storage has to be come with that. So definition comes with the storage to persist actual features created. And the serving layer actually has to serve two different use cases here. So one is model training, and the other use case is model serving. So once model is trained based on features defined by data scientists in this picture, and then model has to be used for prediction purposes as well. And then on top, you see monitoring boxes where you can put a lot of monitoring capability. Either this is a job itself or data quality as well. I hope this architecture gives you a basic sense of how data-centric AI can be enabled. Okay, so this is my last slide. Thank you for listening my talk. So I will end this quote, which is famous Stanford professor's quote. So he said, coming up with features is difficult, time-consuming, and requires expert knowledge, which is true. Applied machine learning is basically feature engineering. So what he said is, if you recall, 80% of time within data science lifecycle is around feature engineering, which means we see a lot of opportunity to provide as common tools and software or infrastructure so that the efficiency of model development can be improved over time. Also, this actually helps to build a better model. Thank you so much for listening.
Wow, thank you so much. That was amazing. If you could stop sharing your screen, I know this virtual audience wants to give you a huge virtual round of applause. That was awesome. Thank you so much for sharing with us today. For the audience, it's time for you to make your way to your next session. Along the way, make sure you accept your connection request and take some time to check out our amazing exhibits. Thanks so much, and we'll see you around.